What does it take to manufacture a steel component that weighs several tons while maintaining exceptional strength, reliability, and internal integrity? Large diameter forgings are essential components used in industries such as power generation, oil and gas, aerospace, marine engineering, and heavy machinery. These applications demand the highest levels of performance because even a minor defect can lead to significant operational and safety risks. However, producing large diameter forgings is far more challenging than manufacturing smaller forged components. One of the biggest challenges is achieving structural uniformity throughout the material. During the forging process, immense forces are applied to refine the steel's internal grain structure and improve its mechanical properties. In large forgings, however, the outer regions receive greater deformation than the core. This can result in differences in grain structure and material properties between the surface and the center, potentially affecting toughness, fatigue resistance, and overall performance. To address this issue, manufacturers carefully control deformation patterns and forging reductions to ensure a more uniform structure throughout the entire component. Another critical challenge is cooling control. After the forging process is completed, the component must cool at a carefully managed rate. In large diameter forgings, the outer surface cools much faster than the core, creating temperature gradients within the material. If cooling occurs too quickly, thermal stresses can develop, increasing the risk of distortion, residual stresses, or even cracking. On the other hand, improper cooling can also lead to undesirable microstructures that negatively impact mechanical properties. For this reason, manufacturers use carefully designed cooling schedules, heat treatment processes, and temperature monitoring systems to ensure consistent material characteristics throughout the forging. The third major challenge is inspection complexity. Since large diameter forgings are often used in critical applications, they must undergo rigorous quality inspections before being approved for service. Detecting internal defects deep within thick sections of steel is significantly more difficult than inspecting smaller components. Advanced non-destructive testing methods such as ultrasonic testing are commonly used to identify hidden flaws without damaging the material. However, the large size and thickness of these forgings make inspection more time-consuming and technically demanding. Specialized equipment, highly trained inspectors, and strict quality control procedures are required to ensure that every component meets the necessary standards. Large diameter forgings may appear to be simple pieces of steel, but behind every finished component lies a complex manufacturing process that requires precision, expertise, and advanced technology. From maintaining structural uniformity and controlling cooling rates to performing thorough inspections, every stage plays a crucial role in ensuring reliability and performance. These challenges are what make large diameter forging some of the most demanding products in modern manufacturing, and overcoming them is essential for supporting the industries that rely on them every day.